This is Algebra Lesson 2-8, Proportions and Similar Figures. Similar figures are figures that have the same shape but not necessarily the same size. The little approximately equal to symbol that only has one of them is the symbol for similar. Think of a similar figure as being a photocopy of something which you either shrunk or enlarged. It is the same shape but not necessarily the same size. A scale drawing is an enlarged or reduced drawing that is similar to an actual object or place. Think of models, model airplanes, HO train sets. Those are all scale drawings. A scale is the ratio of the distance in the drawing to the corresponding actual distance. If you've ever put together a model and the model says 1:32, that means 1 unit on the model is equal to 32 units in real life. So that could be 1 inch is equal to 32 inches, 1 foot is equal to 32 feet. You have to read your scale. Each scale and each model is different. A scale model is a three-dimensional model that is similar to a three-dimensional object. Okay, that would be like when you put together a 3D puzzle, or you would put together a model airplane or a model car. Those are all three-dimensional models. They still have a scale. Everything is done to scale so that it is very, very accurate. Architects use a lot of scale models. They'll mock up a building before they actually build it, including putting things in such as the all of the shrubbery and all of the yard materials and things of that nature to make it look beautiful. They'll also put in the street lamps, and sometimes they even put little people in the scale model so that the people they're trying to sell their project, their architectural design to, can get a full effect of what it looks like. Now you can use proportions to find missing side lengths in similar figures. Such figures will help you measure real-world distances indirectly. Okay? Many things are done indirectly because it's very difficult to measure how tall a tree is. It's not like you're going to climb to the top of the tree and drop the tape measure down, because by the time you got to the top of the tree wouldn't support your weight. All right, so let's look at some similar triangles. In a similar triangle, corresponding angles are congruent and corresponding sides are in proportion. So in this particular triangle here, let's take a really good pay attention to this. We have triangle ABC is congruent to DFE. Okay? One thing you have to understand is the symbol for similar looks like this. The symbol for congruent looks like this. Now, we use the word congruent rather than equal because equal is basically used for equations, where congruent is used for geometric figures. So in this particular triangle, two triangles, triangle ABC is congruent to triangle DFE. That means that angle A here, this is angle A, is congruent to angle D. It makes sense because we have A here and we have D here. Order is important. The order is absolutely critical when you name something that is congruent. Angle B, that would be this angle here, we'll put 2 lines through it, is congruent to angle F. That would be this one right here. And last but not least, angle C here, 1, 2, 3, is equal to angle E here, 1, 2, 3. Okay, those are congruent angles. So if angle A was 36 degrees, angle D would be 36 degrees. Okay, if angle A was equal to 36 degrees, then because they are congruent, angle D would also be equal to 36 degrees. Okay, so angle A is congruent to angle D, angle B is congruent to angle F, angle C is congruent to angle E. And the sides are in proportion. Now the sides in proportion, you can watch and pay attention to this, like A to B is D to F. Okay, A to B, D to F. Okay, B to C is F to E. And last but not least, A to C to D to E. So those sides are all in proportion. That means, what that means is if side AB to DF is in the proportion of 2 to 3, that means side BC to FE also has to be in the same proportion of 2 to 3. That's what it means by the sides are in proportion. This is really important because when we get into solving things, for example, if I told you that these two triangles are similar, I'll just tell you that right now. These two triangles are similar. A, B, C, D, E, F got cut off here at the top, so we'll put F back there, D, E, F. So triangle A, B, C is congruent to D, F, E right here. And we know that we've got 2 lengths on triangle ABC, and we only have 1 length on triangle DFE. But I do know that if I'm going to solve this, I can use a proportion. Okay? I have a tendency to go from small triangle to big triangle, or big triangle to small triangle. Some people go side on small, side on small, side on big, side on big. I prefer going from one figure to another figure, but it's a personal preference. So if I was to keep this small to big, if I went 6 centimeters, that is similar to 9 centimeters. So I would go 6 over 9. And then my 8 centimeters here would be similar to my x centimeters. So I went small, which is 6, over big, which is 9. I'm going to go small again, which is 8, over big, which is x. Okay. Notice that that would be the exact same proportion if I went small over small equals big over big, as long as I kept the sides the same. So I could go 6 over 8, and that's going to be proportional to 9 over x. They're the same proportion because if you'll notice, okay, I'm multiplying 6 by x here, I'm multiplying 6 by x here. So it's a personal preference. I prefer to go from one figure to another figure because I find it a little bit easier for me, and that's basically the way I learned it, so that's why I do it that way. It doesn't make it wrong if you went 9 over x, or excuse me, 6 over 8 equals 9 over x, or 9 over x equals 6 over 8. Okay, as long as you keep the sides that are in proportion in the right place. Notice we went vertical side over horizontal side, vertical side over horizontal side. So vertical to horizontal equals vertical to horizontal. So if we solve this proportion, we have 6x is equal to 9 times 8. 9 times 8 is 72, so 6x equals 72. Divide by 6. So x is going to equal 12. And of course, since it is labeled, we need to label it so x is equal to 12 centimeters. So we found the missing side, which is really, really helpful. Once you understand that you have similar figures, you can set up similar figures in proportions and solve lots of different problems. Okay? For instance, you can use proportions to find the dimensions of objects that are difficult to measure directly. Okay? For example, a tree casts a 26-foot shadow. A boy standing near the tree casts a 12-foot shadow. His height is 4.5 feet. How tall is the tree? So let's draw some pictures here. And I'm terrible at drawing pictures, so laughing would not be good at my lovely drawings here. Here's my tree. Right, my tree, I do not know how tall my tree is, so we'll call the height of my tree h. But I do know that it casts a 12-foot shadow. We have a boy over here, and I'm no better at drawing people than I am drawing trees. The boy is standing by. He's 4.5 feet tall. And he casts a 12-foot shadow. Now, interestingly enough, if the sun is over here, these will create what we call similar triangles because of the shadow that the sun is, because the sun's going to be beating down on the people the same, as long as they can both cast a shadow. If they can't both cast a shadow, that means the boy is in the shadow of the tree. So these become 2 right triangles, and they are similar. So I could do the height of the tree over the height of the boy is equal to the shadow of the tree over the shadow of the boy. Oops, the tree casts a 26-foot shadow. I messed that up. I was going to say, wow, the tree casts the same size shadow as the boy? No, this would be 26. So the height of the tree over the height of the boy, shadow of the tree, which is 26, over the shadow of the boy, which is 12. There we go. Fixed my error there. Alrighty, so cross multiply. So 12h is going to equal 4.5 times 26. So 12h is going to equal, take your handy dandy calculator if you don't know how to multiply 4.5 times 26 in your head, which I'm not always good at. That's going to equal 117. I know 117 is not divisible by 12, So this is not going to be exactly a perfect foot for the tree, but we see that it is 9 3/4 feet tall, 9.75. Now, you might say, well, I could have dropped a tape measure from that tree if I had a tall enough ladder. True, but you can't always drop tape measures from the top of tall objects. If you've ever seen surveyors on the side of the road, they have the little tripod and they have a little laser on it, and then somebody is way down the road with a little post in the ground. They're actually using similar figures to measure distances so that they can determine things for the road that they're working on. All right, so this tree is 9.7 feet tall, 575 feet tall. All right, let's look at number 2 here. A flagpole casts a shadow 102 feet long. A man 6 feet tall casts a shadow 17 feet long. How tall is the flagpole? All righty, I get to draw again. All right, so here's my sun. Here's my flagpole, which means there's wind over here. Flagpole is casting a shadow 102 feet long. Flagpole, I do not know how tall it is, so I'll leave it as H. This becomes my similar triangle like that. All right, a man 6 feet tall, and this figure is not drawn to scale. Okay, so this man is 6 feet tall, and he is casting a shadow that is 17 feet long. All right, so if I want to set up my proportion, I will go from the height of the flagpole over the height of the man is going to equal the shadow of the flagpole, 102, over the shadow of the man, which is 17. So cross multiply, 17h will equal 6 times 102. If I take 102 and I multiply it by 6, I'm going to get 612. So 17h equals 612. Divide by 17. That means h equals 36. That would be a little bit harder to get to the top of. All right, so in this particular instance, the flagpole is 36 feet tall. All righty. All right, now let's look at scales. All right, if we're going to deal with something with a scale, we just need to make sure that we pay attention to the fact that you normally go from the scale to the actual. So if you're looking at something and you're going to put it together, it's normally the scale to the actual. Okay, so 1 inch represents 12 miles. So my scale, 1 inch to 12 miles. That's often how they'll write it on a map. Sometimes they'll write it as a fraction, like 1 inch is to 12 miles. All right, now I normally leave the labels off when I'm dealing with scales because too many labels get really confusing. I just try to remember that I'm going to go inches over miles equals inches over miles. So if I do 1 inch is equal to 12 miles, if the actual distance between two buildings, if the distance between two buildings is 4 inches on the map, so 4 inches goes on the top, what is the actual distance? The actual distance is over x. So I went scale to actual, scale to actual. 1 was the scale, 12 was the actual, 4 is the scale, x is the actual. So there is my proportion. So I can do 1 times x, which is x, is going to equal 4 times 12. 12 times 4 is 48, so x is equal to 48. So the actual distance should be 48 miles. I'll always answer word problems in a complete sentence. Alrighty, number 4 here. A model of a new campus building is 5 inches tall. If 1 inch represents 8.5 feet, so we're going 1 inch over 8.5 feet, or 1 inch to 8.5 feet. If 1 inch represents 8.5 feet. How tall will the building be? All right, so the model is 5 inches tall. So in my proportion, 1 inch is equal to 8.5 feet. My model is 5 inches. That's going to be how many feet tall? So there's my proportion. 1 over 8.5 equals 5 over x. Cross multiply. X times 1 is x. Multiply 5 times 8.5. So that will be, let's see, 5 times 8.5. Well, 5 times 8 is 40. Okay, so 42.5. X will equal 42.5. So the building will be 42.5 feet tall. So as you can see, scale models and scale drawings can be very, very helpful. And you can set up a proportion to solve many, many scale model problems or scale drawing problems or indirect measurement problems. So keep that in mind as you get to those types of problems. All right, here is our closure question today. When is it helpful to use a proportion? Please write that into the bottom of your notes or the end of your notes for this lesson.